So now let us enter into the exercise problem, exercise 1.2. Everyone write it in your classwork. So we have first main, state whether the following statements are true or false, justify your answer. In that we have first one, every irrational number is a real number. So is every irrational number is called as a real number? The answer is true. Every irrational number is called as real number. Every irrational number means what? Root 2, root 3, root 5, root 7. Every irrational number are called as real number, because real number means all the numbers. It includes natural number, integers, whole number, positive integers, rational number, irrational number. All the collection of all the numbers are called as real number. So the first one answer is true. All the irrational numbers are called as real number only. All the natural numbers are called as real number only. All the whole numbers or all the integers or all the rational numbers are called as real number only. All the numbers are called as real number. So the answer is true. So second one, every point on the number line is of the form root m, where m is a natural number. See, number line means what? Number line means it is a line consisting of all the numbers. It consists of all the numbers in the sense it consists of whole number, natural number, positive integer, negative integer. So number line will contains every number. Okay. In the other word, I can say a number line contains all the real numbers. Real number means it includes all the number, natural number, whole number, every number a number line includes. So I can say a number line includes all the real number. That is why number line is also called as real number line. Remember that. So there is no restriction that in a number line there is only natural number should be there, because they have given here there is a point. It seems m is a point. M is a point in the sense m might be any number. It might be 1 or 2. They are saying that the number on the number line is just only natural number. Natural number means it's having only 1, 2, 3, like that. It's having only these number only. They are saying that 0, -1, -2, root 1, root 2, these are all not there in the number line. Actually it is false. A number line will always contain all the real number, all the natural number, whole number, integers. There is no restriction that a number line should contain only the natural number. So the answer is true, because a number line can contain all real number. Got it clear? So third one is every real number is an irrational number. Every real number is an irrational number. Okay. As I said earlier, real number means it is all 0, 1, -1, -2. All the numbers are called as real number, isn't it? So let I write one real number. -1 is also a real number. 0 is also a real number. Root 4 is also a real number. Correct? So is every real number or irrational number? Irrational number means it should be root 2, root 3, root 5, isn't it? -1 is not irrational. It is a negative integer. 0 is not a irrational. It is a whole number. Root 4 again, when we simplify, are going to get 2, isn't it? Which is nothing but a rational number. Again, it is not a irrational number. So every real number is not an irrational. But there are some numbers. Root 2, root 3, root 5 and all, it is an irrational only. But all the real numbers, okay, but all the real numbers are not irrational. Got it clear? All the real number are not irrational number. So again it is false. So let I go to the second one now. Are the square roots of all positive integers irrational? What do you mean by square root? Square root means this one, which I write like this. It's called as square root. Okay. Are the square roots of all positive integers are irrational if not given example of square root of number that is rational number. See, what they are asking us to find is that they are asking us whether all the square root of all the positive integer, means square root of positive integer means root 2, root 3, root 4, root 5, root 6, root 7, like that. All the positive integers which are under the square root are irrational or not, they are asking. The answer is no. Why? I can call this root 2 as an irrational number, isn't it? Root 2 as irrational number. I can call root 3 also to be an irrational number, but I can't call root 4 as irrational because root 4 is nothing but 2. In the previous video I said why root 4 is 2. You can have a look on that. So 2 is not a irrational number, it is a rational number. So all the number under the root, all the positive integers under the root are not exactly irrational. The examples are this: root 4 is equal to 2. Similarly, root 5 is again irrational, root 6 is again an irrational, root 7 is also an irrational, root 8 is also irrational, but root 9 is not a irrational because root 9 is nothing but 3. So every positive integers under the root is not irrational. For example, root 9, root 4, root 16. This number is also a positive integer which is under the root. It is under the root, so I can't say, since it is under the root, I can't say it is an irrational number, because after simplifying I am going to get this as 2, this as 3. So I can't say all the positive integers under the square roots are not a irrational number. If not, give an example. They have asked the example as root 4, root 9, root 16. These are all the examples where it contains a square root. Even though it contains a square root, we are not going to call it as an irrational number because it is a rational number only after the simplification. Got it clear? Okay, so let us go to the next one now. Show how root 5 can be represented on the number line. So we need to show this root 5, which is an irrational number, on a number line. As I said earlier, number line when contains all the real numbers, all the whole number, natural number, integers, rational number, irrational number. It contains all the numbers. It's a collection of all the rational and irrational number. So in this number line, I have to locate this root 5. So in the next video, I will be teaching you how to locate root 5 on the number line. So get connected there.